Hi everybody. In this video I want to give you just a very quick introduction to energy, which we're going to be spending the next 3 to 4 weeks studying. So you've all heard of energy. It's really hard to think of a definition of what energy is because it's not an object that you can hold or touch. Scientists consider energy to be the ability to do work. Now that may sound kind of strange because it's not actually a thing. But if you think about it, work is anything. Stapling something, turning a door, lighting a light bulb, plugging something in. For any work to happen, you need energy. So everything in the universe requires energy. Energy is all around us. Every single process that you do in your life involves using energy. So you already know that there are a number of different kinds of energy. And just to go through a few of them that you're familiar with, you are all familiar with solar energy, right? Energy from the sun. You have all plugged things in, so you've utilized electrical energy. There is heat energy, which is called thermal energy. We just finished learning about radioactive decay, which releases nuclear energy that we use in nuclear power plants. We can harness energy from the wind. And some of you who play instruments and others who like to listen to music, you are very familiar with sound energy. So these are just a few types of energy. Now, all types of energy come in one of two forms, kinetic and potential. And we've already talked about these. Kinetic energy is the energy of objects when they are in motion. I want you on your paper to write down 3 examples of kinetic energy. You can pause the video, you can use the pictures on this screen to give you some ideas, but jot down 3 examples of things that would be using kinetic energy. Second form of energy is potential energy, which we can think of in 2 ways. We can think of it as energy that is stored or energy of position. So we know that when things are higher up, they have more potential to fall. So the higher an object, the greater its potential energy. Again, I want you on your packet to write down 3 examples of potential energy. Feel free to use these 3 pictures as your inspiration, but pause the video and restart it after you have 3 things written down. So all processes that happen in the universe involve energy. The Earth's energy comes from 2 main sources. There is an external engine. So in other words, there's a source of energy that is external or outside of the Earth. And there's a source of energy that's inside the Earth, or an internal engine. We'll start with the external. I'm sure if I asked you where we get most of our energy from, you would say that it's the sun. So the sun is the Earth's major source of external energy. The energy from the sun drives all of the external processes. In other words, it makes everything happen on the outside of the Earth. So things like weathering and erosion and the water cycle, all of these things get their energy from the sun. All weather, including wind and storms, all of that energy comes from the sun. And of course, we wouldn't be here today if we didn't have energy from the sun. So all of these processes are created externally by the energy from the sun. Now, the Earth also gets energy from inside. Most of that comes from when the Earth formed. So we know that when the Earth formed, it was formed by meteors and asteroids that were all colliding together, very, very hot. And we know that the Earth originally was molten. It was all melted. So there is still energy in the core, which we've talked a lot about. So that internal engine, or that internal energy, is still there. The other source of energy has to do with radioactive decay. which we just studied a couple of days ago. So we know that when radioactive atoms decay, they turn into a daughter product, and they also release energy. So as these elements decay inside the Earth, they are releasing energy. So these two sources of energy drive all of the Earth's internal processes, so things that happen inside the Earth. So these are the things that are associated with plate tectonics. So all of the energy from plate tectonics comes from the heat from the core and the heat created by radioactive decay. So if we get more specific, we're talking about things like volcanoes and earthquakes, mountain building. The energy that's used to build mountains comes from the Earth's core. Geysers, when they erupt, the energy comes from the internal engine. And tsunamis. All right, so we're looking at two basic engines that drive all of the Earth's processes. Now, during this unit, we're really going to be focused on energy from the sun. So in class tomorrow, we're going to talk about how stars, including our sun, create energy. And just to give you a quick idea of how this happens, it happens in the process that you're seeing on the screen. Basically what happens is in stars, atoms are fused together. They're joined together. And when that happens, energy is released. Now that process is called nuclear fusion. And what the stars do is they are fusing together hydrogen atoms. So they're taking multiple hydrogen atoms and they're combining them together, and that releases helium plus energy. So all of the stars that we see at night and the sun that we see during the day, they all create their energy in this process called nuclear fusion. We'll talk more about this tomorrow, but I wanted you to get a little bit of an overview so that you're prepared for what we're going to do. Thanks for watching.